Good morning, everybody. I'd like to walk you through the solution for section 5.7, page 384, number 33. It says, spotting a police car, you hit the brakes on your new Porsche to reduce your speed from 90 to 60 at a constant rate over a distance of 200 feet. So there's the main problem that we have. We have miles per hour and then feet. Part A, find the acceleration in feet per second squared. How long does it take to reduce your speed down to 55 miles per hour? And at the acceleration obtained in part A, so that constant acceleration, find how long it would take you to bring your Porsche to a complete stop from 90 miles per hour. So here we go. Let me try to walk you through these steps. The solutions manual is available by the publisher, and there's a link to it from my site. But sometimes it's hard to go through those things. So we got to put everything in terms of feet and seconds. So 90 miles per hour, 5,280 feet, 3,600 seconds in each hour. So we're talking about 132 feet per second. I was on a roll, so I just completed the other ones as well. And then as we start part A, sometimes it's hard to get these answers in one or two steps. So if we can find all three, the acceleration, the velocity, and the position functions of each one of these problems, then plugging the numbers in at the end is going to be a snap. That's the key. So we don't know what the acceleration is. So there's our first variable. Raise the power, divide by the power. The initial velocity here was 90 miles per hour, but we converted it to feet per second. And there's the velocity machine. Now the problem there, it's got two variables in it. And then the position function. Raise the power and divide by the power. Do it again. And don't forget that constant. The initial position wasn't really given, and so we're going to use 0 for the initial position there. So there is the position function. So here's the next thing that we have. It travels over a distance of 200 feet. We've got to find time. The time that it takes to go from 90 miles per hour to 60 miles per hour in that 200 feet span. So grab the position function. 200 feet is the time traveled. We still have those two variables. Grab the velocity, because the velocity at that time is going to be our 60 miles per hour converted to feet per second. And we throw that into the velocity machine. Still two variables. But they're the same two variables as over here. So we have two equations and two unknowns. We can solve them 4 or 5 different ways. Let's solve these using substitution. So I solved this equation over here for the initial acceleration, which happens to be the variable we're looking for. Shove that in for A over here. The t's cancel, the 2's cancel, and then combined like terms, and we get t equals 20 over 11 seconds. Shove that 20 over 11 seconds in for t to get acceleration equals negative 24.2 feet per second squared. So it's accelerating at a negative rate. Some people call that deceleration, okay? So you can say it's decelerating at 24.2, or you can just say accelerating at a negative 24.2. For the computations, we need the negative in there. Okay, so finishing part A, done. We got that value. I think the solutions manual keeps it in the as a fraction. Part B, what time does it take for it to decelerate to 55 miles per hour? And we converted 55 into feet per second. Now that we have that constant deceleration, we just put it into the velocity machine. Set the velocity equal to that 55 miles per hour and solve it for the t value. And again, they like to use the fraction for the t value, so I converted it with my calculator there too. And last, going 90 miles per hour at this deceleration, how long will it take to be stopped? Or I think it says velocity. No, it says stopped. Okay, so when it's stopped, you know that the velocity is 0. And the velocity is 0 right there. Put it in the velocity machine and solve that one for the missing t. It's going to take 5.45 seconds, or 60 over 11 seconds. If there's something on that explanation that you can't understand, shoot me an email. I'd be happy to answer any of your questions. So this week's schedule looks like this. Monday, you're doing the odd problems on the practice quiz. Tomorrow, you'll do the even problems on the practice quiz. Make sure that you're working on Roman numeral 6. Okay, I'm going to post the answers to AP Roman numeral 6 on Wednesday. And hopefully Wednesday we'll have you up and running for some AP Central review problems as well. And then I'll be able to create quizzes for you in that format after we practice on some homework assignments. Hope everybody's doing well. I miss you guys, and we'll talk to you soon. Stay healthy.